Word count, 1,200 words, enigmatic music fades in throughout human history. We've been told time and again what cannot be done. Impossible, they said. Beyond our reach, they claimed. A fundamental limitation, they declared. And yet, here we stand, surrounded by achievements that were once deemed unattainable fantasies. I'm your host, and this is Overcoming Scientific Obstacles and Limitations, an exploration of humanity's relentless pursuit to push beyond the boundaries of the possible. The path of scientific progress is not a smooth, straight line. It's a labyrinth of dead ends, unexpected turns, and seemingly impenetrable walls. But what makes science truly captivating is not just what we discover. It's how we overcome the obstacles that stand in our way. Think of the Wright brothers, told that heavier-than-air flight was a fool's errand. Or consider the experts who insisted that breaking the sound barrier would destroy any aircraft that attempted it. Time and again, the impossible has yielded to human ingenuity. Why do limitations exist in science? Some are technological. We simply lack the tools to observe or measure certain phenomena. Others are theoretical. Our understanding is incomplete or flawed. And some are resource-based. Certain experiments require funding or materials beyond our current reach. But perhaps the most perplexing limitation is psychological, our tendency to accept current boundaries as permanent. The phrase, "it can't be done," has preceded countless breakthroughs that changed our world forever. The invisible world remained largely a mystery until the development of the microscope. Suddenly, cells, bacteria, and entire microcosms revealed themselves to our astonished eyes. What was once beyond perception became the foundation of modern biology and medicine. This pattern of technology shattering limitations repeats throughout scientific history. The telescope unveiled the cosmos. The particle accelerator exposed the subatomic realm. Each instrument pushed back the darkness of ignorance, revealing what had always been there, waiting to be discovered. Earth's gravity is an insurmountable barrier to space exploration. This statement, once accepted as fact, crumbled under the thrust of rockets that carried humans beyond our atmosphere. The enchanting moment, when Apollo 11 touched down on the lunar surface, represented not just a technological triumph, but a victory over the very concept of limitation itself. Today, we're planning missions to Mars and beyond, turning yesterday's science fiction into tomorrow's expedition logs. The boundaries continue to recede before our determined advance. Consider the Human Genome Project, a scientific endeavor that initially required 13 years and billions of dollars to sequence a single human genome. Today, the same process can be completed in hours for under $1,000. This astonishing acceleration illustrates how quickly impossible can transform into routine. Similarly, the computing power that once filled entire rooms now fits in your pocket, processing information millions of times faster. These aren't just improvements, they're revolutions that have fundamentally altered what's possible. Some limitations aren't physical but conceptual. For centuries, Newton's laws of motion were considered the complete description of mechanical behavior. Until, that is, a patent clerk named Einstein introduced his theory of relativity, revealing that time and space themselves were more baffling than we'd ever imagined. Einstein didn't just solve problems within the existing framework, he revealed that the framework itself was insufficient. This pattern of theoretical revolution represents one of the most thought-provoking aspects of scientific progress. Perhaps no field has more thoroughly shattered our notions of what's possible than quantum mechanics. The uncertainty principle, quantum entanglement, and wave-particle duality present us with a reality so perplexing that even Einstein struggled to accept its implications. Niels Bohr famously said, "If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet." These theories didn't simply overcome obstacles, they transformed our understanding of what obstacles can exist. Evolution, too, represents a theoretical breakthrough that fundamentally altered our perception. The mysterious origins of biological complexity, once attributed solely to divine creation, yielded to Darwin's elegant explanation of natural selection acting over vast timescales. This theoretical leap didn't require new technology, just a new way of seeing. Sometimes, the most profound scientific advances come not from new tools, but from new perspectives that render old problems suddenly solvable. Methodological innovation, changing how we conduct science, has repeatedly overcome seemingly intractable problems. The double-blind experiment, for instance, allowed us to filter out unconscious bias, revealing truths that had been hidden by our own expectations. Statistical methods transformed our ability to find patterns in noisy data. Suddenly, subtle effects that would have been dismissed as random variation could be identified with confidence, opening new frontiers of discovery. The rise of citizen science has conquered limitations of scale and scope. Projects like Galaxy Zoo harness the power of millions of volunteers, accomplishing in days what would take researchers years. The boundary between professional scientist and enthusiastic amateur has blurred, creating new possibilities for large-scale research. Similarly, interdisciplinary approaches have dissolved barriers between fields. When biologists speak with mathematicians, when physicists collaborate with psychologists, entirely new disciplines emerge in the fertile boundaries between traditional domains. Perhaps no methodological advance has been more revolutionary than artificial intelligence. Machine learning algorithms now identify patterns too subtle for human recognition, predict protein structures that defy decades of traditional analysis, and generate hypotheses that no human might have conceived. These tools don't just solve existing problems, they reveal questions we didn't know to ask. The limitation of human cognition itself is being supplemented by artificial systems that extend our intellectual reach. What frontiers are we challenging today? Clean energy at scale remains an enchanting goal, the ability to power our civilization without environmental destruction. Fusion energy, promised for decades, continues to hover just beyond our grasp. Yet each year brings us closer to this transformative capability. Solar efficiency improves steadily, battery technology advances, and new approaches to grid management emerge. The obstacle isn't whether renewable energy is possible, it's whether we can scale it quickly enough to meet our needs. Age-related disease, once accepted as inevitable, is now being reconceptualized as a biochemical problem with potential solutions. Researchers are uncovering the mechanisms of cellular aging and developing interventions that may one day allow humans to live far longer, healthier lives. The perplexing question is not whether we can extend healthy lifespan, but how far this extension might go. Are we approaching a new era where century-long lives become the norm rather than the exception? Climate change presents perhaps our most urgent challenge, requiring not just technological innovation, but social and political transformation. The obstacles here involve coordinating global action and developing technologies that can remove carbon from the atmosphere at unprecedented scales. Yet even in this daunting arena, breakthroughs emerge. Carbon capture technologies improve, international agreements strengthen, and public awareness grows. The path forward remains difficult but increasingly visible. Throughout scientific history, we see a recurring pattern: obstacle, innovation, breakthrough. What seems impossible today often becomes possible tomorrow, then routine the day after. This cycle doesn't just happen. It's driven by the courage and creativity of scientists who refuse to accept current limitations as final. What impossible problems might be solved in your lifetime? Artificial general intelligence, interstellar travel, complete understanding of consciousness, the elimination of all infectious disease. I leave you with this baffling thought. Somewhere in the world today, a scientist is working on a problem that experts insist cannot be solved. And yet, against all odds, they will find a way forward. Because in science, the most important phrase has never been "it can't be done," but rather, what if we try a different approach? Music swells to crescendo. Thank you for joining me on this journey through the enchanting landscape of scientific possibility. Until next time, keep questioning the impossible. End credits. Unusual Science, Episode 52, Overcoming Scientific Obstacles and Limitations.